Hi guys, this is George with Troglodyne. I'm going to give you a bit of the presentation I did for Houston.PM last week. I got some really good feedback when I did that. It looks like the most enthusiasm for what I'm working on is not actually for the QA portions and the reduction of workload that you can do with the tool, but the sort of support structure that I've built around this to actually enable a tool to happen. And so as such, I'm going to split this into two videos. The very technical heavy presentation about the math and combinatorics behind the reduction of work that you can do, and then into just sort of the general program structure and all of the different things that are going to enable that, and sort of how I'm going to break it up so that we can actually enable other tools to build on the backs of what I'm building here. So first, in case you're not familiar, the name of the tool I'm building right now is called pairwise, and that's because pairwise test execution is a very familiar technique to anybody in quality assurance or some developers. But the point is that it's a technique that you can use to reduce the amount of configurations that you actually have to test for whatever system under test. So suppose you support a variety of different platforms. Let me give you a pretty complex example here, right here. So, for example, here's a bunch of groups of different platforms like operating systems, a CPU architecture, a browser, and you can have all different kinds of them, right? These all together, suppose you had some kind of megalo software that supported integration with all these sorts of things. That quickly balloons into tens of thousands of possible combinations of functionality, and actually probably hundreds of thousands, if not millions, of permutations. Thankfully, for our purpose, we don't actually care about permutations, because those are just differences in ordering, where the ordering is essentially irrelevant when you're building configurations of systems under test. So all we really need is essentially the combinations, because as you notice, there were multiple sets there of different sorts of functionality we can integrate with, right? Which means it's not actually pairwise that we want, it's n-wise that we want, because we have n, 1 through n numbers of configuration groups that we actually have to mix together to build this, actual configured system that exists in reality, right? So when I looked on CPAN and I looked around, I didn't actually see a good n-wise combination solution. I saw a lot of n choose k, and there were a few that were doing multi-set sort of functionality, but none of them doing the actual combination the way that I wanted and needed for this particular tool. So what I did was I just grabbed my 30-year-old combinatorics textbook and grab the reference algorithms essentially and let it rock, because really none of this has changed significantly. I think the last major advancement in combinatorics I know of happened in the 70s, and that's Chin's algorithm. But anyways, so the point is that I realized that pairwise, when you go to n-wise, that's actually just a standard combination, which, as I mentioned, that's going to be in some of these more complex situations. That's going to be, possibly tens of thousands, hundreds of thousands of different systems under test you're going to have to provision if you want to comprehensively test everything. Well, that's obviously going to take a lot of resources to build, and it's going to take a lot of time to actually cover everything, which, when you think about the pace of changes that actually come in a testing organization, you might have how many commits coming in every day. In a really big organization, this could be hundreds of commits in a day, maybe even thousands. But I've never really known of an organization that big you need a mono repo and thousands of people to make that happen, right? But certainly, I can imagine it being reasonably straightforward to have organizations that have repos with tens to hundreds of commits coming in every day. And so it very quickly becomes non-feasible for you to actually execute, say, tens of thousands of configurations, spin them up, wind them down, make sure they run all the tests, make sure they report them all back to central command in a way that you can actually use the information. That is very, very expensive for a lot of commits that are likely just not relevant to the various configuration sets. That said, there's no actual way of knowing ahead of time any given commit will have an effect on any particular configuration. That's sort of why pairwise testing became a thing in the first place. Was, well, it turns out that it's just like two different combinations of functionality are usually what causes bugs, so just choose any of them, right? And when I thought about that philosophy, I thought, well, NWise is not what we actually want there. What we actually want is something that essentially just chooses basically a bag of one of each as best we can. And so what that actually means we do is we grab the biggest possible set that we have and use that as our maximum bound. So for example, in this set that we have here, our biggest set is going to be like browsers, and there's 8 different browsers here. So that means we're going to have 8 different sets of systems that we would need to configure and test, which when you think about 8 systems and however many tests you have, that actually sounds pretty reasonable, even if you have a very, very large volume of commits coming through, right? So especially if you configure multiple different servers of those in each of those configurations, you can then split the testing amongst those as well and make it happen even faster, such that you could have results almost instantaneously. You know, that's sort of the goal you want here to actually have accomplished. So anyways, the other thing that I want to mention is that my goal here is, I've seen a lot of organizations, continuous integration, like I mentioned, this is sort of a very big centralized affair, right? Where you have one build box and it's just spinning up stuff of whatever configuration is needed to actually test the system under test. Or it's actually just using one configuration and just blowing through it because that's actually what's the most practical. It is not exactly the best test coverage, but it's practical, and that's, I would say that's probably the majority of the situations I've actually seen implemented in the wild, which makes sense. It's a centralized solution. It's only going to have so much hardware. It's only going to have so much it can have access to. You need to actually sort of either decentralize your operation or use a really industrial strength solution like Kubernetes or something, which, to be fair, is becoming a great deal more accessible these days, right? So I think that a very practical solution that'll also have knock-on benefits is to use the existing tools we have as organizations to coordinate work in a decentralized fashion, which, you know, if you're thinking, you already know where I'm going with this, and go ahead and use that as our big cost-saving mechanism, because then we don't need any extra stuff. We don't need a big Kubernetes cluster. We don't need any of that, but we can use them if we want to. There's no reason we can't. There's no reason we can't integrate this with existing CI if we want to. But we could also just use our existing testers' resources, our existing developers' resources, our existing whatever, and just make sure that we have all the configurations we support. We have at least one node on the network doing it, and we're good enough, right? So the way that I'm going to do that is actually by abusing Git, essentially. Well, abuse maybe is not the right word because I'm actually using it as designed. Essentially, there's 2 problems that have to be solved to execute tests in a decentralized fashion with no central coordinator. And that's going to be the way to divvy the tests up amongst the nodes in the decentralized network. And then the other one is going to be reporting the tests back, right? And so in that first problem there with divvying the tests up, that means that you need a way to both identify what configurations each tests are, what tests need to be executed on that, which is essentially what the mathematics all goes into that I was talking about with pairwise. And then the last thing you actually have to do is you have to not lose your train of thought in the middle of a video. Okay, that's really important. But you have to have a unique identifier for every node on the network, and there's several ways of going about this. One that I've seen before is passive OS fingerprinting, which essentially requires network traffic, but it gets the job done. But I realized that there was also another problem in organizations I've seen before, that we can use Git, and there's precedent for doing these sorts of things in Git to solve another problem, and that's by having our unique identifier being a GPG public key. That is either associated with your existing Git user that you're using to make commits, or you just generate one on the fly, right? And then go from there. But the point is, we'll have to distribute these public keys in some straightforward way. And the way that that's actually going to be done, go to the next slide here, is that we're going to use a file much like the mailmap file. So there's a .mailmap file, and that basically just tells Git that if you have multiple committers that have different emails, that they're actually this same guy, right? They're this person, and this is their primary email address, and this is their primary name they wish to be known by. So what we can do is we can make something like a .mailkeys file, for example, and a companion program to check and make sure that it works, or set up something, for example, just to as like a sugar around creating GPG keys appropriately and configuring them in Git. But the point is, making Git extension commands is fairly straightforward. I've done that before. Mailmap is a good precedent that I can use. So I think that essentially we can distribute these keys, use them as our unique identifier for all of this testing, and then use those to sign Git tags, which we will actually use to report everything back to what essentially amounts to central command, but without actually having a central coordinator. Because basically anybody who pulls down the latest changes and the latest tags will start to see test results roll in, because a tag will be pushed that says, oh, hey, I executed these tests and these are the ones that failed. Something like that, right? I'll probably have it fairly compressed and machine-readable format because, I mean, who wants to read all that stuff? I mean, you can filter Git tags, but I imagine there is some level of forbearance that I need to engage in. But we'll see how that works out when I implement it. Right now, the thing that I primarily have implemented is the mathematics, which is why I went over that mostly in the talk. But it seems like the biggest enthusiasm we had in the talk was for this idea of distributing GPG keys without a central coordinator, and all the different things that this actually can enable you to do as an organization, not just communicate encryptedly without having to essentially do any extra work, but also allows you to coordinate basically any kind of work that is operating under the same kind of constraints as our problem set here. And so I've already mentioned sort of the way I wanted to go with the pairwise tool and all that kind of stuff. I'll just briefly mention here sort of that the reason why I couldn't find a lot of the things I needed on CPAN is because a lot of these problems and the constraints that I was dealing with rub right up against some NP hard problems. So whenever you see that in general in programming, you start to see all of a sudden people are not writing a lot of programs for this. Usually you're going to see maybe some interfaces to stuff like GMP or the NYU Math Pack or something like that, where it's, you know, the professionals have actually written a solution for doing this. But in this case, number theory is still relatively obscure to most people. They don't sort of connect two and two together as to how this actually is relevant to their lives. And indeed, in this case, a lot of people don't think, you know, these are words in bags, right? These are lists of words. How can this possibly be number theory? Well, it turns out, I mean, you can assign a cardinality to any kind of word you want to, and then it's just a matter of essentially vertexes and how are these vertexes connected. That's what these sets we're building actually look like. For example, let me hop in here to VS Code and just sort of show you. Here's sort of an example of a list that we would create as a result of our little algorithm to build a configuration to actually run some tests. And you can see here's sort of the the offset in the test array and how many we need to pick off of the test array appended to that. But the point is that this bag right here is essentially a vertex in a graph, right? So this is what's called Ramsey's problem, but also these days it's known as cliques, which is essentially graph theory. You can see here it's finding a clique is the idea of, well, what are all the different vertices that are highly connected to each other? And by highly, we mean it's just sort of like, well, how many vertexes do they share with other vertexes, etc. In particular, our problem here is what's called the anti-clique, which is independent sets. So it's what particular vertices don't actually touch any other vertices, which, as you can see, sort of, again, from the output here, we don't want to share any kind of other browser like on our longest set. We want to make sure that those are only shown once, and so that we minimize the number of connections we have there. For all the other stuff, it's less important, and so that's sort of going to be the constraints that actually allow us to solve this without having to resort to NP hard approximation heuristics and things like that that make your life really very difficult as a programmer. Anyways, so to get back into the thing that people apparently are actually really excited about, I've already mentioned, all the precedent, all that. I think I'm going to actually introduce this as a standalone tool. I don't know if I'll be able to get anything actually mainline in a Git until it actually catches on, has traction, but there's certainly precedent for actually having Perl in the Git distribution. I'm not sure as to what kind of standards they want for the commands that they actually include mainline. Might have to write that in Rust or C or something like that, but that's no big deal. And then sort of the last step in the chain here is, after we've got all these mechanisms that actually allow us to distribute these tests and to report the results correctly, we actually have to integrate this into whatever's running our assertions, right? So for Perl, that's going to be prove and Yath, which Yath is sort of the new generation of test runner. It's a good deal faster, has a various other sort of new generation goodies for us. But essentially, for both of these, what is going to need to be done is you build a plugin, you load the plugin when you run the tests, and things are just reported to the right place. It's much like the concept of a coverage reporter, or, for example, one of my modules on CPAN, which is a TestRail API. It also comes with a app-proof plugin TestRail, which you can just do prove, I believe it's -p TestRail, and it will look at a configuration file and automatically upload the results of whatever test you ran to TestRail. Isn't that great? But again, that's a sort of central command. It's got a central coordinator. It'd be great to just run this and it just blasts it out. Doesn't need a central coordinator. You've just got all of a sudden now a Git tag done, and you don't have to think about it. No money needs to be spent. Very, very much more efficient production process there. You could also, and then the question is, okay, so if I'm an organization that is pushing out a bunch of commits every day, right? How do I make sure that the testing actually gets run on all of these different machines, right? Well, the best way to do that is probably going to be a Git hook, like a post-receive hook or something like that, where it runs our little pairwise tool and says, oh, hey, it looks like you need to run some tests today, and here's the tests that we're going to give you today based on your random seed that's pre-computed or whatever it is. And then we'll go ahead and run the tests, and we'll report the results, right? We may fork those off in the background process so that it doesn't prevent your developers from doing their work, right? And then, you could also do something like automatically log bugs if you have failures and so forth, but, that's better covered by other people, so I'm not going to go into any of that. But I probably will provide at least an example Git hook of how to use this to make it work in your organization. And yeah, as I mentioned, we're going to end up making sure to use Git tags to do this decentralized reporting. And then we're going to need a mechanism of some kind to deal with the fact that some nodes will go offline and won't come back online long enough. There's sort of two ways you can deal with this. And the first one is to just ignore it. Don't really care about it. And just since the model already is relying on repeated iterations, eventually going to get all of your configurations covered, you can accept some amount of slop in your production process and it'll probably be fine, right? On the other hand, what you can also do is you can set things up such that if, for example, some timeout is reached, it'll make sure that, so suppose you have two different machines that are configured that satisfy a configuration. We split the tests list in half for both of those, and one of the machines never came online, right? So what we could say is, well, it looks like this amount of time has passed and we never got a report back from them. So what we're going to do is we're going to run them on the platform that we actually do have and move from there. So there's several ways you can actually deal with this problem. And I'll make sure that we provide a mechanism like maybe a flag or a subcommand in the tool, such that you can say, well, can you go ahead and execute everything that's sort of outstanding? Do it either LIFO or FIFO or whatever. But that's the point, is to, if you need completeness, give the option to actually deal with that. And so, we come to the end of my presentation. If you like my work, you can head over to the pairwise repository, which I don't have public just yet, but will very soon. And you can sponsor that with GitHub sponsors, or you can just send me a PayPal if you love all the stuff that I do. And hopefully you guys won't be doing that for this project just yet, because it's not done. No reason to help me out for something that's not done, because if that was the case, I'd probably have a Patreon, right? But anyways, so again, thanks for all the support, guys. I really love Houston.PM. I can't recommend doing a presentation there highly enough. Got really good feedback, and it is really helpful for you to understand what are people actually really enthusiastic about, but also get good feedback as to sort of whether your technical aspects were really solid. And it looks like I actually really got it this time. So very happy with the presentation, and I've got some other videos up just to cover this, but this is going to be the canonical video now. All right, see y'all later. Well, as soon as I turn off OBS.